All right, going through 11.3 problems. This is polar functions. All right, so plot each point, find the corresponding rectangular. So 5 pi over 6 takes us to here. -3 goes the other way. So this is 3 long. This is now pi over 6. Pi over 6 is 30, 60, 90, 30, 1.5, 1.5 root 3. So that would be root 3 over 2 times 3, my bad. 3 root 3 over 2, -1/2. Those that need to work that out. X equals 3 cosine of pi over 6. Y equals negative, because we're down in the negative zone, 3 sine of pi over 6. Moving onwards. Sorry, -3 over 2. All right, 5 arctangent of 4/3. Where does tangent equal 4 over 3? All right, so this actually works out very nice. It's almost like I planned it. Arctangent is 4 opposite over 3. That's pretty cool. So that's done. That's just a 3, 4. Don't need to know the angle. It's just a method to get to a point. All right, 7 pi. That's a little tricky. 1, 2, 3, no. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So we're pointing this way. Whoops, we go the other way. So it ends up right here at 1, 0. Wish it was more complicated than that. And last but not least, root 3 at 2 pi over 3. So 2 pi over 3 is here. That makes this angle pi over 3. And this is 2 root 3. So x equals negative cosine pi over 3 times 2 root 3. Y equals sine pi over 3 times 2 root 3. Hope that's right. Yep, that's right. Which would give me, I could just do this with 30, 60, 90. Let's see, 60. So that's the short side. So that's half of that. So that's negative root 3. And then we multiply that by root 3. So that's 3. Math, baby. Okay. Plot each point with the given rectangular coordinates and find 2 sets of corresponding polar. Tricky. Negative root 3, -1. Having a little trouble drawing my 3's today for goodness knows what reasons. Okay, arctangent, well, wait a minute, let me slow down. If this is root 3 and this is 1, that means this is 1/2. No, doesn't work out that way. So it looks like I just have to do it the old-fashioned way. We'll find this angle here, arctangent, the y, 1 over root 3. Well, that's pi over 6. And then the magnitude, oh, I was doing this correctly. I just forgot about the magnitude. The root 3 squared, 3 plus 1 squared, 1 square root. 3 plus 1 is 4 squared is 2. So this is too long. So let's go with the simplest answer. Let's say that it could be 2, 7 pi over 6, or -2 if we were at pi over 6. Both those answers are good. 3, 4, that looks familiar. I think I've seen this somewhere before. 3, 4. Makes this 5. So theta is the arctangent of 4/3. And I'll just leave it like that, just like above. So this is the same problem. 5 arctangent 4/3 if you want to blast that out, by all means. And then down here would be -5. And I'd have to go 180 degrees around, pi plus arctangent 4/3. 0, -2 down here. So that one's real simple. We'll go with 2, 3 pi/2. I always think I'm going to get these backwards, so be careful. And then -2 at pi/2. In other words, there and go down. And you could call it lots of other things. If you have different answers, they're not wrong. Then 2, 0. That's here. So that's fairly straightforward. 2, 0. Or keep doing the negative thing. Let's go to pi -2. -2, pi. All right, onwards. Graph set of points, blah, blah, blah. -3 is the same as 3. It's just a circle. Theta equals -pi/4. That'll be down here. And that is any and all radius, so it goes on forever in each direction. R² + 8 = 6r. Looks like math time here. R² - 6r equals -8. -6/2 equals -3. Put it in a box. -3² equals 9. Okay. R² - 6r plus 9 equals -8 plus 9. What's in the box? -3. Careful, there's a negative there. Squared equals 1. So this could be two different circles because of the squared. When I solve it for r, I would go square root, and I'd get either r - 3 = 1 or r equals r - 3 equals -1. So this would be r equals 4. This would be r equals 2. So at the end of the day, we're looking at circle at r equals 2. Sorry about that. Circle at r equals 2 and a circle at r equals 4. Moving on. Find an appropriate window, use a graphing calculator. So this one, you just graphing. It's really not that hard. But let's see what we got. 1, 2, 3, 4. So this is a cardioid. No, I don't have it memorized. Well, I'm actually cheating. I have notes sitting off to the side here, but I would just graph it with a calculator. Polar coordinates and all that. We call it a cardioid. It looks like a heart lying on its side. And up here, got a rose graph. Looks something like this. It's a 4-petal rose graph. All right, so this is a great name. Dimpled limaçon. Get that beard in there. And then one of my favorites, racetrack. Of course, not called a racetrack. Called a lemniscate. All right, and then simple circle will be on the X coordinate. I recommend you get that one locked into your brain because it will show up in your somewhat near future. On an AP question, well, it'll help to know it. All right, onwards. Breaking a sweat here. All right, use analytic methods, blah, 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 which is a lot of just praying that this works. R equals -3 over cosine of theta. R cosine of theta equals -3 if we multiply by cosine up here and here. Therefore, we end up with x equals -3. It's just a vertical line. I have some trouble with my hands today. They don't want to do what I'm telling them to do. R squared equals 1. Change R squared to x squared plus y squared. All right, that's just a circle with radius centered at 0,0. Kill. Kind of bothered how fuzzy this is. I'd zoom in more, but then I lose it. All right, R squared sine of 2 theta. Hey, I happen to know there's an identity that goes sine of 2 sine of theta, cosine of theta equals 2. I can cancel those 2's out. And I get R, I can distribute the R's. R cosine of theta. Why did I put the cosine first? You'll see. R sine of theta equals 1. Well, that's x times y equals 1. All right. And that's a hyperbola. It's a hyperbola that's been turned sideways because that's going to be y equals 1 over x. So that's this one here. Hyperbola. All right. R squared equals -4. R cosine of theta. X squared plus y squared equals -4. X. That's a circle centered somewhere else. Well, let's keep going. X squared plus 4x plus y squared equals 0. I'll come back to that. 4 over 2 equals 2 in the box. 2 squared equals 4 plus 4 plus 4. X plus 2, because that's what's in the box, squared plus y squared equals 4. Divide by 4, divide by 4, divide by 4. Nope, didn't need to do that. Throw it up here. X plus 2 squared plus y squared equals 4. Circle. With radius of 2 centered at -2, 0. Kill. R equals 8 sine theta. I know that y equals r sine theta. and y over r equals sine of theta, to which point you're probably saying, so 8 times y over r squared equals 8y. And there we go. X squared plus y squared equals 8y. X squared plus y squared minus 8y, negative 8 over 2, negative 4. Negative 4 squared equals 16. Plus 16 equals 16. X squared plus y minus 4 squared. Let's see, am I running out of space? I bet I am. Equals 16. Done. Circle with radius equals 4, centered at 0, 4. R equals 2 cosine of theta plus 2 sine of theta. I got that same trick over here where I can say x equals r cosine of theta. X over r equals cosine of theta. Y equals r sine of theta. Y over r equals sine of theta. R equals 2 x over r plus 2 y over r times r times r squared equals 2x plus 2y. X squared plus y squared equals 2x plus 2y. Sorry, everybody, I'm going to do it very quickly. X minus 1 squared plus y minus 1 squared equals minus 2x and 2. All right, fine, I'll show you. You should really go here first, and x squared minus 2x, y squared minus 2y, negative 2 over 2 equals negative 1, negative 1 squared equals 1, plus 1, plus 1, plus 2. Hope you're happy. Sheesh, greedy people. All right, done. Circle with radius equals 2, centered at 1, 1. Square root of 2. Ugly. Square root of 2. Better. Getting there, boys and girls. Getting there. Find appropriate use graphic calculator, principle of curve, sketch the curve, then type of curve. Right? These are not on our list of curves. Right? From our notes. We graph this, we get this. This is a negative because it goes to the left. Horizontal parabola. This is a positive vertical parabola. This is horizontal ellipse. All right. Now calculus. Notice we haven't really done much. Okay. Find the slope of the curve at the point. 0 and both plus or minus pi over 2. Y x equals r cosine theta, cosine of 2 theta, cosine of theta, dx d theta equals negative cosine 2 theta. I'm leaving that one alone. I'm just taking the derivative of that one. Minus, derivative of that one is 2 sine, negative 2 sine of 2 theta. Leave that one alone. Y equals r sine of theta, cosine of 2 theta, sine of theta, dy d theta equals, leave it alone, cosine of 2 theta, cosine of theta. I shouldn't have done that. Now I got to do it everywhere. People are appreciating this. Minus 2 sine of 2 theta, sine of theta. Wow. Okay. I'm going to change colors to try and make some sense of this. At theta equals 0. Wow, I just plugged in theta. Dy dx. Well, let's slow down. Where can I write it? Dy dx equals dy d theta over dx d theta. So at theta equals 0, let's plug it in here. If I put it in here, I get 0, 0. So can't divide by 0. Dy dx is undefined. Oops, sorry, getting a little messy here. At theta equals pi over 2, dy dx equals, now let's check it out, pi over 2, plug it in here. Pi over 2 is cosine of pi, negative 1. Sine of pi over 2 is 1. All right, cool. You know what, I'm going to ignore that because I think at pi over 2, this is going to cancel out. Cosine of pi over 2 is 0. Sine of pi is 0, so this is gone. So as long as the bottom's not 0, which is not, the top is, dy dx is 0. And at theta equals negative pi over 2, I believe we get the same thing. You can show all your extra work if you want, but yeah. Okay. X equals 3, 1 minus cosine of theta, which is 3 cosine of theta minus 3 cosine squared theta. Dx d theta equals negative 3 sine of theta plus 6 cosine of theta sine of theta. Wow. Y equals 3, 1 minus cosine of theta sine of theta equals 3 sine of theta minus 3 cosine of theta. Okay. So dy d theta equals 3 cosine of theta plus 3 sine of theta. It seems too easy. Yeah, because I wasn't done here. I got interrupted. 3 sine of theta minus 3 cosine of theta sine of theta. Sorry about that. Plus 3 sine squared theta plus minus 3 cosine squared theta. Let me see if I can track that down. Derivative sine cosine, got it. Derivative Derivative of cosine is negative sine, so that gives me positive 3 sine squared. Derivative of sine is cosine, gives me negative 3. Yeah, okay, got it. All right. Just like before, I'm actually going to shortcut this a bit. At pi over 3 dy dx equals undefined. At, this is fascinating, they're giving r values. Huh. I don't really need to give theta. No, whatever. What do I know? At 2 pi over 3 dy dx equals 0. Let's just look at that one. All right. All I care about is dy because that's on top. As we said before, dy dx equals dy d theta over dx d theta. So actually, I do care about the bottom. Bottom can't be 0, so I just plug it in and go. At pi dy dx equals undefined again. At 3 pi over 2 dy dx equals 1. By the way, very typical on these problems is to get values like pi over 2, pi over 3, pi. When you plug them in, they end up canceling out. You know, like, oh, look at all this mess. Well, that's a 0, that's a 0. Oh, that was easy, we're done. So that's not unusual. All right, 1 to go. Find the area of the region described. Boy, I hope you make time to do these problems. What's a cardioid look like? This is a upside down heart. Yeah. So 1/2, I throw it out front. This is 0 to 2 pi to get all the way around. How do I know that? I'd graph it and find out. Make sure. And then it's just the equation, 2 plus 2 sine of theta squared d theta. I do all sorts of fancy math here. I will write it out. If you blast it out on a calculator, I'm fine with that. Recognize what the answer is, and it'll help you. Well, it'll help. So integral 0 to 2 pi, 1/2, 0 to 2 pi. I'm confused, hang on. I don't even know what I just did. I simplified this thing somehow. I would have multiplied this out and seen where it takes me. Looks like I used a reduction formula, so I'm not going to do that. When you're done, you should get 6 pi. And I would just use a calculator. Inside the 8 petaled rose. And this one, kind of good to see. You only want to do 1 petal. All right, you want to do 8 times that. So we get 8 times formula 1/2 integral. So 0 to 2 pi. If there's 8 of them, I'm going to go with 2 pi divided by 8, pi over 4. 2 sine of 4 theta d theta squared, which is what causes all the problems. So I do a power reduction formula here. Nope, 2 pi. Done. Yeah. Inside 1 loop of the lemniscate. What a great name. Love that. This does this. So I played it when I graphed it. Starts here at 0. Think about that. Plug in 0, we get 4. And then here it gets to theta equals pi over 4. So we just want 1 loop. So that's going to give me, remember, going to go like this. That's going to give me the top half. I got to multiply by 2. So it's 2 times 1/2 integral 0 to pi over 4. 4 cosine of 2 theta quantity squared d theta. Just realized I ran into my next problem. Oops. Equals. Okay. So I'm going to have to say this is number 24 and apologize. After all is said and done, you'll get 2. Draw a line. Over here we get a dimple de limaçon. Sorry, get the whole French thing going on there. All right. And I can do the whole thing from 0 to 2 pi. I really do like doing this. Don't ask me why. I like just saying, let's double it from 0 to pi. Don't forget the 1/2. 3 minus 2 cosine of theta quantity squared d theta. 11 pi. All right. There's all sorts of power reduction formulas, and I actually don't mind showing all that work sometimes. It would take forever here, and I haven't quite left the space. I want to be clear that this will almost always be a calculator problem. So if you got 3 decimals here for these two, or these, this one you should get 2. It's not a problem. Shared by the circles. This looks interesting. Try not to go over there onto the other one. R equals 1. R equals 2 sine of theta. So we want this area here. Let's see what's going on. How do I know where they intersect? Well, 2 sine of theta equals 1. Theta equals pi over 6. That's where they intersect. So that'll just give me a funky little area. It doesn't really help me. I gotta think about this one. I'm gonna have to zoom in. This is what makes these problems so hard. All right. There's the top one, gonna break it. And here's the bottom one. Gonna break it. So the area for the top one starts getting accumulated like this to here. So this area is 1/2 integral from 0 to pi over 6. There's only half of it, so I'm gonna have to multiply everything by 2 of this one, 2 sine of theta squared d theta, plus 1/2 the integral. It's gonna go from pi over 6 to pi over 4 of the other one. Pi over 2, pardon me, of 1 squared d theta. All right, so this is right there. This is right there. And like I said, when we're done, we multiply it all by 2. If you blast this out, and again, there's all sorts of math I could do here, you should get 2 pi over 3 minus root 3 over 2. Sorry about that. All right, another one, shared by the cardioids. This looks hideous. All right, so cardioid 1 does this. Cardioid 2 does this. They're roughly the same size. I drew it so I can see what I'm talking about here. So if they're exactly the same size, I could just find one of them multiplied by 4, but I don't think I can do that. Yeah, actually I can. It's the same region 4 times over, even though I drew it badly. So let's just pick this one here. It doesn't matter which one I'll pick. I'll pick the 1 minus cosine theta over here, multiply by 4. So the area is 4 times, where do they intersect? 2 times 1 plus cosine of theta equals 2 times 1 minus cosine of theta by cosine of theta equals negative cosine of theta. Cosine of theta plus cosine of theta equals 0. 2 cosine of theta equals 0. Basically, it's when theta equals pi over 2. So 0 to pi over 2. I could pick either one, really. Well, I don't know. I'll definitely got the one that's going to the left. That's the -1. 2, 1 minus cosine of theta squared d theta. Could do all sorts of fancy calculus, but after I'm done, I'll just get 6 pi minus 16. Whatever decimal you get is totally fine. Sorry that ran off page. Yeah, those are challenging problems. I'm gonna have to do those in class or something like that. Anyway, that's it. Enjoy.